Welcome to the tokenized economy. Here is today's explainer on proof of work versus proof of stake. Now, to get our heads around this, let's just do a super quick refresh. Blockchains are basically networks of computers, right? We call them nodes. And some of these nodes have an absolutely crucial job. They have to validate and add new blocks of transactions to the chain. But hold on, that brings up a massive question. If there's no CEO, no central server, no single boss calling the shots, how on earth does this global network of computers decide who gets to add the next block? How do they all agree on what's real and what's not? Well, that's where something called a consensus mechanism comes into play. You can think of it as the secret sauce, the rule book that lets a decentralized system actually agree on things and stay secure. And today, we're going to break down the two big ones.
So, first up, proof of work. You've definitely heard of this one. It's the original, the one that powers Bitcoin. And yep, it's all about the miners. At its core, proof of work is exactly what it sounds like. It's all about work. We're talking raw computational effort. You have these special nodes, the miners, and they're all using incredibly powerful computers to compete in this massive race to solve a super complex math puzzle. The first one to find the solution wins. They get the right to add the next block to the chain, and for all that effort, they earn a reward. A great way to picture this is like a giant global lottery. But here's the twist. You don't buy tickets with money. You earn them by doing all that heavy-duty computational work, which, by the way, uses a lot of electricity. So the more computing power a miner has, the more lottery tickets they can get, and the better their odds of winning. This whole process makes the network incredibly secure, but it also means it uses a tremendous amount of energy. Okay, so that's proof of work. Now let's completely switch gears and look at a different approach, proof of stake. This is the mechanism that networks like Ethereum use today. And right away, the big difference is that instead of miners, we have validators. So how does this all work? Well, instead of spending a ton of energy on computers, participants here lock up or stake their own money, a certain amount of the network's currency. You can think of it like posting collateral. The system then selects one of these validators to create the next block, and your chances of getting picked are often tied to how much you have staked.
Exactly. It's not about who has the most powerful computer anymore. It's about who has the most skin in the game. By staking their own assets, validators are putting their money where their mouth is. If they play by the rules and honestly validate transactions, they earn a reward. But, and this is the key part, if they try to cheat the system, they can lose their stake. It's a pretty powerful economic incentive to behave. Okay, so we've looked at two very different models, but it's really important to remember that they are both designed to solve the exact same problem. How do you get secure, decentralized agreement? So let's put them side by side. When you boil it all down, the crucial difference is the source of security. Over here with proof of work, security comes from a physical cost, the massive amount of energy and computing power it would take to attack the network. But with proof of stake, security comes from an economic cost, the risk of losing a huge financial stake if you act maliciously. And look, this difference in design has some really big real-world consequences. A lot of the newer blockchain networks, especially those being built for finance and big enterprise, are choosing stake-based models. Why? Well, for starters, they're way more energy efficient. And on top of that, their economic incentives can often be easier to line up with existing regulations and business operations. Ultimately, this gets us to the core philosophical question at the heart of blockchain design, doesn't it? What's the better foundation for trust in a world with no central authority? Is it security through the raw physical cost of energy, or is it security through the direct economic cost of an investment? Understanding that choice really explains almost everything about how different blockchains are built. To keep digging into these kinds of topics, make sure you subscribe for more short explainers just like this one. And hey, let us know in the comments what we should break down for you next. Thanks for tuning in.